towards Open Vocabulary Multimodal 3D Object Detection with Attributes. 3D object detection is essential for autonomous systems. Current methods assume closed classes and rely on predefined anchor sizes. This makes it hard to detect unseen objects. At the same time, attributes such as motion or spatial relations are equally important, but remain underexplored. Our goal is to detect both novel objects and their attributes without depending on per-class anchor pairs. We introduced OVODA, the first framework that utilizes Open Vocabulary 3D object and attribute detection. We designed techniques such as foundation model feature concatenation and prompt tuning to discover novel objects. We propose new strategies for attribute detection such as perspective-specific prompts and horizontal flipped augmentation. Finally, we contribute OVAD, the first benchmark dataset for Open Vocabulary attribute detection. OVODA takes multi-view images and LiDAR point clouds as input. A class-agnostic proposer generates single object boxes. Proposal features are aligned with foundation model embeddings for novel object discovery. Complex event generation then builds attribute proposals from temporal sequences and object pairs, enabling both space and novel attribute recognition. OVODA is trained with 4 key losses, 2 for objects and 2 for attributes. They are feature alignment and a contrastive classification loss. Together, this objective allows unified learning of objects and attributes. Since no dataset exists for attribute detection, we create OVAD. It extends nuisance with over 84,000 annotations across 10 attribute classes, covering motion states, spatial relations, and rider presence. On nuisance, OVODA outperforms baselines in all Open Vocabulary settings, especially when no anchor size is available. For attributes, it achieves significant improvements in success rate and further improves with feature concatenation and prompt tuning. In summary, OVODA is the first framework for Open Vocabulary Multimodal 3D object detection with attributes. It detects unseen objects and novel attributes without anchor pairs, introduces the OVAD benchmark, and advanced comprehensive 3D sense understanding for autonomous systems.